In this video, I am going to explain how to solve the epicyclic gate train problems in algebraic method and tabular method. Now let us first see the problem. The problem describes involving an epicyclic gate train where an arm carries two gears labeled as A and B. Gear A has 35 teeth and gear B has 46 teeth. The arm rotates at 200 revolutions per minute in the anti-clockwise direction around the center of gear A, which is fixed. The goal is to determine the speed of gear B in this configuration. Next, the problem changes the condition of gear A. Instead of being fixed, gear A rotates at 300 rpm in the clockwise direction. The new goal is to find the speed of gear B in this revised configuration. Here in this problem there is two conditions are given. In the first condition gear A is fixed and the second condition gear A rotates 300 rpm. Now let us see that how looks like this gear train is. See the figure. The arm C it's connected to the two gears gear A and gear B. This gear A and gear B are external teeth and meshed together with the help of the arm C. Okay. This is the given problem. Now for all the problems, first of all we have to write input data. Any sort of problem, any course, this is the best approach to solve the problem. First one, after thoroughly read the problem and note it down what is the data is given. Now you can see in this problem, this following data is given. Number of teeth of gear A is given 35. Number of teeth of gear B is given 46 and speed of arm C is given 200 rpm in anti-clockwise direction. The direction also important. And what conditions also mentioned? First condition, speed of the gear A is 0 and second condition, the speed of the gear A is 300 rpm clockwise. These are the two conditions are given in the problem. So this is the entire data is given in the problem. Then next step is to be found. What you are going to determine in the problem, that we have to note it down. Here what you are going to find out, speed of gear B in first condition and speed of gear B in second condition. These two conditions, what is the speed of the gear B, we want to find out. That is the to be found. Then go for the solution. This is the sequence of steps of solving any problem. If you follow any problem, there is no mistakes. Sometimes what happens in the given problem, so many things we need to calculate. But some things overlook, we know, but we are missed some points to determination. Okay, so for avoiding that, you have to follow this approach to avoid any miscalculations or mis and omitting or all these things. Okay, so best approach is to follow this any problem. First note down given data, thoroughly read the problem, just note down the given data, then to be found what you are going to find out, note it down, then go for the solution. Okay. Now the solution, this problem may be solved using following two approaches. One is algebraic method, second one is the tabular method. In the problem is not mentioned clearly, any method you can use and you can solve the problem. If particularly mentioned in the problem, then you can use that method and solve the problem. Now in this, for understanding of the viewers, I will explain both the methods. Sometimes in the problem, if not mentioning any method, you can use and you can solve the problem. Generally, algebraic method are used for the small number of gears involved in epicyclic. Go for the algebraic method. If it is more number of gears are involved in epicyclic gate train, better you can use the tabular method. We'll see that one by one. First, we'll see the algebraic method. So, in algebraic method, let us first find out NA is equal to speed of the gear A, NB is equal to speed of the gear B, and NC is equal to speed of RC. And assuming the arm C to be fixed. First assuming that arm C is fixed and speed of the gear A relative to the arm C, that is NA minus NC, and speed of the gear B relative to arm C, NB minus NC. Since the gears A and B revolve in opposite directions, then the speed of the ratio of speeds of driven gear to the driving gear is equal to the number of teeth of the driving gear to the driven gear in negative sign because of the opposite direction. That formula used here. NB minus NC by NA minus NC is equal to minus TA by TB. So this NB minus NC and NA minus NC are the relative speeds of the gear A with respect to arm C and gear B with respect to arm C. Here negative sign is used, these two gears are rotating in opposite. If the same direction, use the positive, opposite direction, use the negative sign. That you remember. So now speed of the gear B when gear A is fixed. When gear A is fixed, the arm rotates at 200 rpm in the anti-clockwise direction. Okay. Then you can assign NA is equal to 0 and NC is equal to plus 200 rpm. So here you have to use the sign convention. Here I am taking the anti-clockwise positive, clockwise is negative. It need not be the positive and negative. As for your convenience, you can take. Some people maybe take clockwise is positive, anti-clockwise negative. Someone is following the anti-clockwise positive and clockwise negative. As you wish, whatever you want, you can follow. And finally, whatever the direction is there, accordingly you can use the sign convention. Okay. Now in this problem, I am consider anti-clockwise is positive, clockwise is negative. Accordingly, I assign the sign. Now we can use the NB minus NC by NA minus NC is equal to TA by TB. Now substitute the data. NB we want to find out. NC is plus 200 and NA is 0. That data you can substitute. Number of teeth A and B is given. That has been substitute. So from this you can find out the NB. NB is equal to 352.17 rpm. It's coming positive. That means in anti-clockwise direction. Speed of the gear B when gear A is rotating 300 rpm clockwise instead of the fixed, the second condition. Then you can use the same formula NB minus NC by NA minus NC is equal to minus TA by TB. Substitute the data. NB is minus 200 by because it's clockwise negative, so minus 300 minus NC is 200. Okay. Now simplify, you can obtain NB. NB is equal to 580.43 rpm. In first condition, the speed of the gear B is obtained 352.17 rpm. In second condition, the speed of the gear B is obtained 580.43 rpm. Okay. So this is the two speeds in the first condition. Okay. Now, in first condition and second condition using the algebraic method. Okay. Now we can verify the same speed answers are obtained or not in tabular method also. Next we will go for the second method, that is the tabular method. The name indicates tabular method. We have to prepare a tabular before going to determine the speeds of the gear B. Now see that how we can construct the table. Now we can use the first column is the step number and second column is condition of motion and the remaining is the speed of gears or elements in your epicyclic gate train. How many elements are there, that you can mention here. Here in this present only 3 elements are there. I written arm C, gear A, gear B. Now there is a 3 steps. All the problems are having these 3 steps. And condition of motion are also same for all the problems. The first condition is arm fixed. Whatever speed is given in the problem, but first you are assuming that arm is fixed and gear A rotates through plus 1 revolution. This is the first condition you can assume. And based on the condition, you can find out the speed of gears or elements. So arm C. So because arm is fixed, speed of the arm C is 0. And gear A is given plus 1 revolutions. Then okay, gear B you can find out by using this formula minus TA by TB. Minus means the speed of the gear B is the opposite to speed of gear A, so negative sign minus TA by TB. Next, second condition, arm fixed and gear A rotates through plus X revolutions. In the earlier first condition plus 1 revolution. Now we can X revolutions. Okay. So now we can arm is fixed, so that arm is 0 and the gear A rotates through plus X revolutions. Instead of plus 1, it's a plus X revolutions. If the A is X revolutions, find out the speed of the gear B is at minus TA by TB into X. Next, third condition, That is add plus y revolution to all the elements. You can all the elements plus y. Okay, now I added y, this x plus y and y minus dA by dB by x. Okay. Now you can see that the last row, that step number 3, is gives the speeds of the elements. Okay, arm C, the speed of the arm C is y, and speed of gear A is x plus y, and speed of gear B is y minus dA by dB into x. These are the equations. Okay. Now applying the boundary conditions, apply the given conditions and determine x and y. Once if you know x and y, then you can substitute in here and find out the speeds of the different elements involved in the epicyclic gate drive. Okay. Now let us see that in the speed of the arm C is 200 rpm is given. Okay, that NC, that is equal to y is equal to 200 rpm. Okay. Now you can see that two conditions are given. In the first condition, gear A is fixed, that means NA is equal to 0. And based on this condition, find out the y value is already 200 rpm, and what is the x value you can calculate. Speed of the gear A is x plus y. So x plus y is equal to 0. Then x is equal to minus y, that is equal to minus 200 rpm. So x is minus 200 rpm, y is plus 200 rpm. Okay. Now can find out the speed of the gear B is NB is equal to y minus dA by dB into x. Now here substitute x and y values, T and TB. Then you can obtain the speed of the gear B. So the speed of the gear B is obtained 352.17 rpm. Next, second condition. So the speed of the gear A is 300 rpm in clockwise, so minus 300 rpm. So according to this condition, again you can find out the x and y value. Speed of the gear A is x plus y is equal to minus 3. X plus y is equal to minus 300. Okay, and x is equal to minus 300 minus y. So x minus 300, y is 200. So x is equal to minus 500. So now calculated according to second condition, what is the x value, what is the y value calculated. Then you can find out the speed of the gear B is substitute data in the given formula, NB is equal to y minus dA by dB into x. Now you can substitute the data, then you can obtain the speed of the gear B, that is 580.43 rpm. Now compare these values in earlier algebraic method, both are the same values are obtained. Okay, so now you have to use either tabular method or algebraic method, and you can solve the epicyclic gate train problems. Only remember, for simple gate trains go for the algebraic method, and remaining all you go for the tabular method. I hope all of you understand how to solve the epicyclic problems.